Hello and welcome back. This time it looks like we're dealing with a quadratic and completing the square to help us get a turning point. Okay, so let's write down this equation first. We've got 2x squared minus 3x minus 8, and that equals 0. One thing that'll help us out with completing the square is this a value of 2. Let's get rid of it. Let's divide everything by 2. So we get x squared minus 3 on 2x minus 4 equals 0. Now, the key thing of completing the square is looking at this value here. That is our new b value. So if we think about a perfect square, a plus b in brackets squared, this is the same as a plus b in brackets with another a plus b in brackets. This gives us a squared plus ab plus ab plus b squared. We can gather up some like terms. A squared plus 2ab plus b squared. You'll notice that this always has a 2 out the front. It's always double our terms in the brackets. So a and b, they're there, and there's 2 of them because you're doing that process twice. So if we want to get that second term in the brackets, we have to divide by 2. So what does that mean? That means we'll be working with x minus 3 on 4 in brackets squared minus 4 equals 0. Now this, you might think, oh great, I've done it. Let's double check. Let's see what happens when we actually expand these brackets. So when we expand, we'll get x squared minus 3 on 4x minus 3 on 4x plus 9 on 16 minus 4 equals 0. Let's gather those like terms. X squared minus 3 on 2x plus 9 on 16 minus 4 equals 0. I'm seeing a problem here, guys. This term here just appeared. And that's no good, because that means there's a problem starting from here. So all of this, oh my gosh, it's completely wrong. Not really. All we have to do is go, okay, if I've added a 9 on 16, how can I keep my equation the same? Well, that's really easy to do. So let's write down everything again. X squared minus 3 on 2x plus 9 on 16 minus 9 on 16 minus 4 equals 0. And now, this equation here is the same as this. There is no difference. All I've done is add a term, but within the same line of work I've subtracted it. So overall, there's been no change. Now, the great thing about this part here is we know that that is a perfect square. So now we have completed the square. Wow, what a great name. Maybe, I don't know, up to you guys. Anyway, this bit here, let's factorize this as a perfect square. X minus 3 on 4, close brackets, squared, minus 9 on 16 minus 4 equals 0. We can combine these two constants. Let's do that now. X minus 3 on 4 in brackets squared minus 9 on 16 minus 64 on 16. What is happening with my 4s? There we go. Negative 9 minus 64, 73. So I'll have x minus 3 on 4 in brackets squared minus 73 on 16 equals 0. So A, complete the square. Well, I've definitely done that. B, use the result to determine the exact solutions to the original equation. Our original equation is 2x squared minus 3x minus 8 equals 0. There's only one variable there, it's x. So if we rearrange our equation from down here and get x on its own, we'll be done. They will be the exact solutions. Now exact is specific. It means it doesn't want a rounded answer. It doesn't want decimals that are rounded. It wants exact. So let's see if something odd happens when we work with that. So let's start rearranging. Let me just draw a line there. So I'll rewrite the equation up here. X minus 3 on 4 squared minus 73 over 16 equals 0. Let's add 73 on 16 to both sides. X minus 3 on 4 squared equals 73 on 16. Now we can square root. We want to get the x eventually on its own. So x minus 3 on 4 equals the square root of 73 on 16. Now here's the rub. You've got to be careful here because when you apply a square root, there are always two possible answers, a positive and a negative. But if a square root's given in a question, maybe the question says find the square root of 25. It's asking for the positive result there, not all possible solutions. But if you are applying a square root, you must show that there are two possible solutions to it by putting a plus minus sign at the front. Now we're almost done. Our x is almost on its own. Let's keep going. X equals 3 quarters. We're adding 3 quarters to get rid of that negative 3 quarters. Plus or minus the square root of 73 over 16. I just realized that 16 on the bottom, we can simplify that a little bit and then simplify our answers. So x will equal 3 plus the square root of 73 all over 4. And our other solution would be 3 minus square root of 73 all over 4. And now C is done. Oh, sorry, B. Use the result to determine the exact solutions. And there they are, exact. We haven't calculated what square root of 73 is on our calculator and written it as a rational number, a whole bunch of decimals. We've just left it as square root of 73. Finally, we've got question C. Determine the turning point and indicate its type. Well, let's write down our equation that we're working with again. X minus 3 on 4, close brackets, squared, minus 73 on 16 equals 0. Now, if you know the turning point is this part here, that's our h value, and this part here, that's our k value. Now, I should include this sign here because that sign is really important, as is the sign in front of that value. The general equation of a turning point form is a, open bracket, x minus h, close bracket, squared plus k. And the turning point is given by h, comma, k. So hopefully you can see what's going to be the case here. The turning point of this equation will just be 3 quarters and not negative 3 quarters, and negative 73 over 16. And that will be the coordinates of the turning point. Finally, its type. Is it a minimum or is it a maximum? So the a value will determine whether it is a min or a max. If the a value is positive, it will be a minimum. If the a value is negative, it will be a maximum. So if we look in front of this, oh, there's an invisible one there. It's definitely not negative, it's positive. So that would mean that this is a minimum. And we're done. That's it for today. Thanks for joining me, and I will see you next time.